So I want to introduce now the second expert working group and the panel around it, which is wireless networking. And I will let it for Simon, as the chair of the wireless networking group, to introduce the panel itself. But Simon Saunders is is an independent telecoms advisor and the chair of the wireless networking group. The secretariat for this particular group is being provided very capably by Digital Catapult. I'm just following on the same line of David Happy, so I'm okay. So without further ado, Simon, take it over.
Indeed. Thank you very much indeed, Dritan. And yeah, we got to queue up this panel session earlier on, and now we get to go a bit deeper. What you were hearing before was really sort of wireless as a plug-in to the AI topic, and now you're going to be hearing the reverse. So thinking of AI as a sort of service to the wireless networking industry. So I'm joined by a very expert panel from across different parts of the industrial ecosystem, with a collective centuries of experience in the wireless world. So what I thought we would do in this panel is actually divide it up into three broad topic areas. One, first of all, I want to hear the sort of cheerleaders tell us the opportunities that AI presents to the world of wireless networking. What could we hope for from this? How could our lives be immeasurably improved by the advent of AI if done right? Secondly, to turn to the dark side of what's going to make that hard, and we heard some views on those difficult things earlier on. What are the things we'll need to take care of? What are the things we'll need to keep in mind? What are the things we'll need to avoid in the process of bringing those two worlds together? And then thirdly, to sort of look to the future and actually get a bit practical about it and say, what's the path to success here? How can we, avoid the challenges, address the challenges, but get the benefits from AI? And I don't think any of us will be sort of uncritical cheerleaders for this, but there are real opportunities to be seized. So let's start with our panelists introducing themselves and their interest in this. Keep it nice and crisp like the previous panel, if you would, so that we can maximise the time available for the discussion. And we'll also keep a good 10 minutes at the end for questions and comments from the audience here. Fantastic. So let's introduce us.
Thank you, Simon. I'm Chris Murphy from VRV Solutions, and I've been in telecoms for about getting on for 25 years now, working on data-driven optimization and how we can improve performance.
Fantastic. Doug.
Right, so Doug Pulley, I'm an independent advisor. I am 35 years as a deep nerd in wireless, but quite schizophrenic these days, as I sit on both on both the AI and the wireless networking groups, and I've spent a lot of time in wireless baseband and AI for that recently.
Thanks, Doug. Lorcan.
Lorcan Burke, Broadcom, or recently VMware, so looking after strategy and architecture for our service provider customers.
Brilliant. Good to have you here. And Paul.
I'm Paul Petras. I'm a co-founder and the CEO of NetAI. NetAI is a spin-out from Edinburgh Uni, where I still have an associate professorship. So, yeah, I guess I'm not that old in the sector, although actually before embarking on the research adventure, I worked for a large telco OEM, and then I thought it was boring, so then I did PhD and all that kind of stuff, and then it's kind of coming full circle now because I'm kind of mixing the both worlds. So.
Fantastic. Well, fully featured panel. So let's think, what, gentlemen, are your views on if we can get it right, if we can get the data, if we can get the compute infrastructure, if we can handle the security issues? Put those to one side for the moment and tell me what your hopes and dreams are for bringing AI to the wireless world.
I think that you made reference, and Yui made reference to the complexity, the however many million of parameters that we've got in the network, and you highlighted the drive towards predictability rather than optimality. That's such a word. I think this is an opportunity to cut through that, and it will have to cut through that because networks are becoming more configurable as slicing comes along. we're delivering differentiated services over a common network. So we're going to necessarily have to grapple with that. And that is a challenge that's I think AI can help to deliver, in that we can ask questions like, how would this network perform in certain configurations under certain stimuli by demand by users in particular locations with particular characteristics. And when you can ask those questions in a safe environment, in a lab with a digital twin, for example, that opens up a lot of possibilities to break out from that conservative sticking to the known and not grappling with what's possible. So I think that's a big one for me, and an exciting area.
Thanks, Chris. So it sounds like your key hope is in the taking a network and optimizing it in real time for maximum smoke, as it were. If you like, it's broadly the SON use case, if I can put it that way.
Yeah, in real time, but also over longer time scales. I think those are probably as important as each other. Maybe time will prove one to be more than the other. Perhaps the near real time will be the main focus. But the more we can model our networks, and it's not just about building realistic models, but representative models of our networks, which AI can absolutely play a role in. When you've got that representative model, it opens so many doors for near real-time optimization, not just coming up with the answers, but checking them as well. You know, so if an intelligence agent has made a prediction that if we change something or we may take a particular action in our network, actually we could ask an AI what it thinks and say, does it have any undesirable side effects, before it's actually pushed down to the network.
Okay.
And that's a kind of a complement to using that model to actually derive the optimization in the first place.
So the AI may also be providing some of the assurance that the operators need on top of the AI doing the optimization.
Yeah, as long as it's not the same one, because you don't want to be marking your own homework.
There we are. Very good. Thanks, Chris. Doug, what are your thoughts? Maybe there's other domains you have.
So, I mean, there's obviously a lot of talk about native AI now, and probably the opposite of my experience is probably the opposite of Dean's earlier, where he says, I hear everything about the nuts and bolts and very little about the OSS, BSS. My experience is the other way around. Maybe it's all about seeing your bit in lights. But I mean, I think the thing with AI is there's a lot of focus on Gen AI and large language models or whatever. They are great hammers, but not every problem is a nail. If you start to look at where we start to see where things might go through what's happening in 3GPP, we're on to release 19, but in release 18 there was the study on AI and machine learning in the air interface, and that focuses on starting those very early steps to plug in pieces to make bits go better. I mean, it's a good starting point to try and to look at beamforming and child state information, compression and prediction. So we're starting to see where this might go, but that's very much a bionic ran, for want of a better word. Making certain little pieces go better. So it's when you go full native AI, the real benefits come from, and I think it was alluded to in some of the previous conversation about when you break down. And this is my hope, is that we will break down the conventional barriers, conventional block diagrams, conventional stack layers, because they're all done by humans who couldn't possibly understand the complexity of what they were trying to achieve. They just needed to make it manageable to engineer, to design, to test, to verify, to deploy. And I think that's where the real benefits come from. And actually, if you do a bit of work on physical air processing, replacing individual blocks as a sort of a like-for-like swap out, that block is a DSP block out, and I'll put some machine learning in there in its place. You might get a little bit of gain, but you get the really interesting gains when you take a bunch of blocks together and replace that by a piece of AI.
Interesting. So, I mean, this is a sort of variant on Nick's question to me earlier on. Do you see, like, in the end, the opportunity is so some people in the room will know what I mean by a Motorola software radio, where you had one box and an antenna stuck into it, and everything else is digital. Similarly, have you got in mind one box which has one big AI in it and some bits and some waveforms at either end?
That takes us down a dark path, and maybe I'll save that for the dark part of the conversation. But I think in terms of that. I think what will probably need to happen is this benefit of by collapsing things together will probably mean we need to redraw the battle lines for disaggregation going into 6G. That you'll need to reaggregate and then maybe draw different APIs and to disaggregate again.
Interesting. So not necessarily no boundaries, no layers, but some different ones would be necessary.
Yep.
Great stuff. Thank you. Lorcan, what are your thoughts? Where are the opportunities for you?
I mean, as some of the starting points I see that are kind of already broken areas, and maybe it's the pre the digital twin bit, but at least network planning and dimensioning and capacity planning, right? So, and then understanding where you get digital assets, where you're going to actually put radios, what coverage and capacity objectives, right? I notice we're all on edge on Vodafone in here, right? So I'm getting 10 kilobits, and I go on the Wi-Fi, I get 300 megabits, right? So there's something there that wasn't a planned results, but somebody didn't have it in their objectives in the network. So I think if we can do a better job around capacity planning, dimensioning, maybe some forecasting, we've done a bit on that, Paul, right? We've tried to get away from maybe the RIC and SON evolution and into getting people some tools in their hands, right? Around thinking about how they forecast better and then how you get better physical assets to deploy things on.
So that's really interesting. So you've got this this need to map the network topology from today's world of these sites have these boxes that have these functions, and you want to distribute those functions in a flexible way across that compute, storage, interconnect infrastructure for good outcomes.
Yeah, exactly. I mean, we spent the last couple of years building the dish network in the US. It's a bunch of very distributed data centers, really, right? So half racks with a bunch of compute in it. It's nearly all software, right? So bar a lot of Dell servers in that case. We've got similar things going on with VMO2 in the UK. So with some decent funded programs around accelerating some of that work. And that's where I put, or how do I define this edge? Where do I put that compute? How does all that get planned and then integrated? And then how do I decide what network functions get deployed where for what amount of time?
I mean, some of what you say, it comes with the territory of virtualization, cloudification. Anyway, what's the extra bit that is AI particular?
I think literally how do I plan and how do I do release management and dependency management? At the moment, I mean, most dependency management in these software networks is hand cranked, right? So I mean, if you're lucky, you're parsing stuff in GitHub and you're hoping for the best, and there's CSAR files for automation of things, but really, these software networks and how they work with the underlying hardware is still pretty poorly defined and managed. It's a fairly complex problem. So even doing that, I think, with AI and then helping you plan and dimension it with AI would be easy starting points.
Very good. Very good.
Yeah.
And Paul?
Yeah, actually, I was having an interesting discussion when I arrived this morning, I think, with Joel. Problems are kind of the same. They just, networks got a bit more complex, and then you have, layers of different technologies that need to work with each other. So now, okay, you had tools, you had, let's say, mathematical models that work quite well, but right now you can't use those tools anymore because you will not get answers in, a time that kind of, those answers will be still meaningful. So AI opens up this opportunity to basically manage deployments at machine speed with very little human intervention. And also, you can now start to solve those problems in a cost-effective way. So, you can say, okay, I'm going to solve this problem. I'm going to just throw this much resources and make sure that, I can support the service. But then, you're over-provisioning, so you're not running an infrastructure in a cost-effective way. So now if you understand ahead of time, and that's kind of going back to what Lorcan was saying, if you're able to anticipate demand for a resource or for a particular application, and you're able to automate allocation of specific resources to cater for that application ahead of time without human intervention, I think it's a game changer.
Yeah. Splendid. Well, lots of opportunities. So let's turn to the dark side. Let's mix up the order a little bit. We heard a little bit of spirited discussion earlier on where Yui and I were having a slightly different point of view as to what the kind of limiting factors are on getting the sorts of benefits you've been talking about into the real world of operator wireless networks. Which are the ones that worry you in terms of those limiting factors, and how could they manifest themselves?
Go for silicon first, right?
It's always the silicon. It's always our fault. I mean, the The very, very, very obvious elephant in the room that was touched on this morning is the sheer cost, complexity, and the energy consumption required to do AI in the RAN, or AI for the whole network for that matter, with the current AI paradigms. And I think that's a very important qualifier. I think if you look at the fact that you want lots of data, you need to collect all the data on the base stations, you need to take all that data somewhere where the models get trained, you need to disseminate the models afterwards. That whole process, I mean, if you look at some of the structures and diagrams being put into bodies that try and specify how these things work or might work in future, they're just horribly complex. So we're just adding a load more complexity to try and achieve something that, according to UI's numbers, were marginal gains. Yeah. So I think there's that has to be an area of focus, because it's not going to happen otherwise. I think that's a big deal. And also, if you look at some of the approaches normally an air interface, for years and years and years, they've been, handcrafted to be a one-size-fits-all. This air interface will work for, all base stations ever. But we put lots of knobs on, which we've now also heard this morning are far too many knobs to try and adjust and optimize for a certain circumstance. So then you start to look at what people are starting to propose for AI solutions, and they're still locked in a one-size-fits-all mentality. They're trying to create training regimes where you can get the model to generalize over, all vehicle speeds, all channel environments, etc., because you wanted one that works everywhere the same. And that's by definition going to be very data hungry, etc. It's like, maybe we should just stop a second and maybe recognise that AI is a very broad church. All the limelight is on Gen AI style models and things at the moment, but there's lots of other stuff out there that's really useful, and maybe you should use the right tool. And maybe data seems to be the problem. Everybody's seen data as the solution, but I think data sounds to me from all the conversations, it's the problem, and maybe you should get the AI to do more of the heavy lifting than the data. And you don't want to. And if we're reliant on a world where you've got monolithic large models that are unexplainable when they're wrong, then I think that goes against the grain of also what we heard this morning from people who have to do network operation. That doesn't work for them. So why would we offer it them?
Thanks, Doug. You've neatly turned a dark side element into an opportunity there. Yep. From the challenges of the complexity to, if you build AI that's meant for wireless, then you can have bespoke air interfaces for every cell, if I read you correctly.
In the limit?
In the limit. Very good. What do you think, Chris? What are your concerns about getting there?
Well, you mentioned the data aspect, and that's a AI generally depends on data quite heavily, and this is the problem. And Yui mentions the data this morning in her keynotes about the data's all over the place. It's in the deep in the network, it's in the OSS, it's in spreadsheets, and so getting to the data is a problem. It can also be noisy. It can be incomplete, and it can be noisy because there can be. There can just be bugs in how the data is generated and exposed in the infrastructure. It can be incomplete because it's not a number one priority to generate the data. Delivering the communication is the priority. So we can be looking to AI to deal with those problems. It's also voluminous, and it's going to get worse if we're not careful, because we're looking to do more and more with our networks. Telecom Infra Project has set up a working group last year on metaverse-ready networks, and the sort of services that are envisaged in metaverse networks are very rich, very immersive, and they will depend on very continuous high grade of service. And if they don't deliver that, then the perception is going to be extremely noticeable to the user. And you mentioned the chunking of the network, and the ability to chunk is going to be, you have to chunk, you have to make, to break the problem down, but if you chunk too much, then you miss those problems which are going to impair the service that you're trying to deliver, which the MNOs have to do to drive up their revenues. So but there are some interesting technologies in terms of data reduction. We have to do distributed analytics, keep the data, take the analytics to the data, take the AI to the data rather than bring the data. And as you said, it's about deciding where to spin up the communication resource, but also the AI resource.
Chris, this thing about data is the problem, and I get it, but just qualify that a bit for me, because I would have thought there's an equally valid perspective that is, the great thing about these networks is they generate vast quantities of data, which we mostly throw away these days. After creating a 5-minute counter out of our base station KPIs, we never see the data again. Isn't the big opportunity with AI is its ability to assimilate those vast quantities of data and do something useful with it?
Absolutely, and we should be seeing the pessimistic side only here. We should rise to this challenge that there is a lot of data, but avoid falling into the pitfalls of consuming vast amounts of data or killing the network's connectivity by transporting it all around the network. And that's where the ingenuity is going to come. And because they are so complex, we talked about that this morning, the complexity. You've got what are the network functions doing? What is the radio interface? What are the impairments there? How is that changing? How are the users using the network, and how is that different from how they used it yesterday, last week, an hour ago? So there's an awful lot of hidden variables in that, and if we can throw all that data at an AI, then those hidden variables will become we'll be able to learn that and be able to make use of that to make the predictions that Paul was talking about, and be able to be responsive and anticipating the problems and heading them off. I mean, I guess we've crossed over from the dark side to
a little bit, yeah. I'm going to keep it a little dark still. Paul, what keeps your weight on these things?
Bite my tongue a few times.
You go for it.
Because it's easy to blame things going wrong on the data. Actually, I think it's a bit more nuanced than that. A model will be, unfortunately, right now, a model will be as good as the data we use to train it. And I think that's probably still a fallacy, because currently neural networks don't really work like semantic behaviors. They learn from data distribution. So all of a sudden, like if you talked about generalizing, all of a sudden you move a model that you trained somewhere else, and the data distribution is different, it's not going to work, right? So you could argue that, okay, you can't put, for instance, AI in the physical layer because it's energy hungry and so on. It doesn't have to be, because you can train offline and you deploy once and that's it. So you only use it for inference. And then there is a big challenge of like, okay, how do I collect all this data? I need to store it and so on. Probably I don't want to spend too much time kind of thinking about opportunities, but if you understand how to collect the right data for the problem that you have at hand, then you don't really need to collect all these vast amounts of data that flow through a network. It's probably, a lot of it is completely irrelevant. You just need to understand, okay, what is the problem that I'm trying to solve? So what kind of information do I need? And think about it. So in the end, like, you're trying to optimize the problem, but you don't have, like, let's say you don't have a very sort of a formal objective function to solve that problem. And that's where AI is actually good, because it doesn't really need to know what it is. It just wants to know where you want to get to. So that's great. I think the bigger problem, and I think this is kind of not only for telco, but for anything that is kind of critical infrastructure type of thing, is explainability. So you took all the data, you train a model, and it worked great, and all of a sudden, let's say you have a new application like TikTok shows up and messes up all your traffic mix, and you were making predictions, and all of a sudden those predictions don't make sense anymore. Why? Because again, it learned from the data. So now if you're not able to understand what that AI is doing and how an input is affecting the output, that's a big problem. So I think, explainability is like the big elephant in the room across multiple domains, and especially in telco. And I think to some extent, I mean, it's funny because we were speaking with other people. I mean, I'm so excited that this event is happening, but we've been like banging the drum about, hey, you need AI in telcos for the past 3-4 years. And now it's like people care about it. And I understand why it took some time. People are skeptical, right? Will I take like a black box that says AI on the tin and just deploy it and let it do my work? if I don't understand what it actually does. So I think to me that's probably like a big challenge now. How do we make all those neural networks explainable and build confidence into basically using them, right? So to some extent you can say, okay, I mean, you can do pilots and you can use them, for instance, as co-pilots, whereby they make some decisions, but you don't need to close the loop. It's going to inform an expert on some decisions, and then once you got to a stage when actually you've built that confidence, you say, okay, I can close the loop now and let the machine do this menial task, and I can focus on other things which actually are a bit more complex and a machine would not be able to do on its own.
Interesting, Paul. This point on explainability, I'm actually going to say operators are very used to dealing with black boxes in their networks that they really can't explain. They don't know how the schedulers in their networks do their scheduling. They don't know how the turbo decoders do their decoding. Isn't their talent, as it were, to manage a network composed of a bunch of black boxes and cope with managing that despite the things they don't understand about the concept?
Right. Yes and no. So I think there is that sort of opacity because oftentimes, so I don't want to name shame anybody, but you can think about, I'm aware of one of the, the big telco OEMs will come and say, oh, this is the box that's going to use some AI and help you reduce your energy consumption. But you as a customer, you have no idea what that does for you, how you can configure it, how you can tune the knobs. At best, you can say, okay, at the end of a month, I can see how much I saved. And actually you're thinking, well, hang on, I was already doing some manual work. And the difference between that manual work and what this black box is doing for me, it's, marginal. Why would I trust it, right? So to some extent, in our case, for instance, okay, the technology is patented, right? So you can say, hey, look, this is the model that we use, and you can have a look at it. You might not be able to change stuff or replicate things because, okay, it's, some of the technology is patented and so on, but you actually can understand what's happening inside the box. And if you have some knowledge, you can try to generate, for instance, some counterfactual inputs and understand how those variations in that input actually affect the output and what you can expect, for example.
Thanks, Paul. Look, and if we cover all your care-abouts in terms of keeping you awake nights on this?
I think that there was a few bits there. We do operate, these networks are fairly constrained in terms of physical assets, transmission assets. So when we think about all the data that gets shipped around, I've had people friends in hyperscalers who said, don't worry, you only need a gig of traffic for all this management infrastructure, just give me all the data and I go, there's only a gig of traffic to the site. Right, so then they said, well, can't you just get a 10 gig link to the site? Well, no, I can't, because that's 6 months in an argument with my transmission supplier. Right? So which tends to lead towards a couple of things, right? If I build ironically, build an Open RAN base station today, it's still double the power, right? I've a lot of extra accelerators in there. I have a lot of, and it's not being used all the time. If I want to optimize that kind of new base station with its new scheduler, I can maybe think about using near real-time RICs and non-real-time RICs or whatever, right? But that's more compute I have to add, and I have to figure out where I put that as well, and it's more data. I think there's clearly something. Paul ran pre-training and putting assets out at the very edge that don't actually use that much power, and then having some link with the silicon with that. It does strike me. We have a lot of the ARM assets or efficiency assets in this country. We could do a lot better job around how to really construct or optimize those things.
Fascinating.
Plus, we did build the first base stations with Orbitel, right, in 2G. So,
right. Yeah. Let's remember that history. Oh. So, listen. The one thing you all haven't mentioned is skills, and I know we're going to be talking about that after lunch, but I want to roll Doug with it. So when I worked for said hyperscaler and did some AI projects on optimizing some networks, I was very secure in my domain-specific knowledge and how useful that was going to be in the discussions, and how I could point out which bits of this huge amount of data were likely to be useful and so on. And the ML experts nodded politely and went away and did their things anyway. The outcomes were great. The networks got better. The data was ingested. I could not begin to explain why the networks got better. They didn't get better in any of the ways that I could explain. My domain knowledge turned out to be positively harmful to the process. So what's the deal here? Talk about retrading wireless guys into AI. Is that the way to go?
Wow. Well, okay. If they don't, what are they going to do for a job?
Yeah.
That doesn't make it right.
No, it doesn't make it right. But so if 6G becomes native AI, and if all the Phi and the Mac, for example, in a base station are all built out of types of AI, then somebody at least needs to operate as a system architect for that.
Yep.
Right? Somebody who knows what a base station is and does, and what it needs to do, and what's the big wide world out there, the ugliness of propagation, all the rest of it. Yep. That's still important to structure and identify what it is that needs to do the processing. I think you said earlier about AI will just be the thing. I remember back in the day where everybody said, oh, DSP, and everybody wanted to be a DSP engineer. Right? And that was a huge, big deal. And now DSP is just another tool that a wireless system architect builds a base station out of. It's just, well, of course you do. And that's a piece of DSP, and that's a piece of risk-based software or whatever. It's like, it's just another building block. That's an antenna, that's a duplexer, that's it's a system engineering problem. And system engineers need to understand the AI.
Do you think people still need books on antennas and propagation? No, I'm not.
Yeah, no. And a very good book. And a very good book it is too.
Thank you. So listen, we're going to turn to questions from the audience momentarily, but before we do so, I'm going to give you a moment to make one or possibly two recommendations for how we steer from the dark side to the light side in this and get the opportunities. Did you nail all of the recommendations? What would you have the community do? Go.
So yeah, I guess probably I'm the best one to start on this because of the nature of the startup. So we're a small fish now, and we're as I said, we're kind of trying to explain people, hey, look, I mean, there are opportunities here. What we sense is that there is still a lot of inertia in the industry. So people are thinking like, well, I mean, we invested all this money into kind of building 5G, so now why would we kind of change everything and adopt AI and work with like startups who have small teams and so on, when we can actually go to whoever were our suppliers and ask them to do some AI for us. And those guys, again, because they are big and clunky and so on, they take time to innovate and so on. So I think what my recommendation would be is for people to kind of actually talk and be a little bit more open to collaborating. And I think ORAN is trying to do something in that sense, because you have all this philosophy of open interfaces and embedding intelligence across the stack. So that kind of creates a sort of a level playing field for players across multiple domains. But at the same time, just remember, we will not see full-scale ORAN deployment probably before 2030. And we have problems that we need to solve right now. And actually, a lot of the existing tools are okay. It's just that, you have the interface and so on. It's just kind of, replacing what's inside the box with something else. And through collaboration, you can say, hey, good, okay, let's try a new solution. Let's say try a new forecasting engine, which works pretty well, and see if it actually, provides the benefits that we anticipated. There's no real cost, right? It's just, okay, I mean, there is a cost because you need to deploy some engineers, collect some data and so on, but you can gauge the benefits really quickly. It's just that you have to have a little bit of sort of, open-mindedness and say, let's give this a try, see how it goes. And then if it doesn't, at least we learn something.
Thanks, Paul. So open minds, it's good to talk. Lorcan.
I back to that skills thing. I think we need a bit of a injection of earlier in career people, just younger people do more work, right? So I mean, really, I've done 5 startups in this, and I've worked for most of the large NEPs, right? Paul might have said it wasn't that exciting anymore. Still exciting, right? Just exciting in a different way, right?
Yeah.
But we need more earlier in career people. Yep.
Very good. Doug.
New brains.
We should avoid another 3G moment.
Yep.
Right. So for those who are unfortunate enough to be around, 3G was born in a circuit switch world just as the internet was taking off, which meant halfway through 3G, somebody realised, we really ought to put some high-speed packet access on this so that you can do internet over 3G. we're in a situation now where suddenly, and I think it was alluded to earlier, there's this disconnect between the 10-year cycle time of 3GPP and this constant spiky innovation rate of AI. If you bake, and I've heard people suggest this, if you bake in details of models and training regimes and all the rest of it in a lot of detail into a standard, you might look very silly in 2 years' time.
But, yeah. Yeah.
Okay.
My recommendation is that we start thinking holistically, or more holistically than we have been, thinking about the intent of what we're doing with our networks and how we achieve that with the resources we have and the demands that's placed on our networks. And I think I draw some inspiration from joint communication and sensing, where the lines blur between delivering the connectivity and sensing in service of delivering the connectivity. So everything is about delivering the vertical application or applications, and how do we use the resources we have and the AI that we need. When do we need to get data? When do we need to train models? When do we need to exercise models in order to deliver the vertical?
Fantastic. Thank you. Well, armed with those recommendations, let's see what the audience... Now, we've got quite a few questions burgeoning, I can see. So if we can direct a question to a panel member and get one answer rather than do a whole debate, then we can pack in a few more questions. So bring on the microphones. Well, we've got one already. Thank you. No.
So we often hear the term AI native in the context of 6G networks and cloud native in the context of 5G networks. So do we see a correlation here that for an operator to be AI native, let's say in the future, they have to be cloud native?
No. Look, I mean, you could start deploying AI in any of your IT and OSS today, right? There's really nothing stopping anyone. And linking that to, as we said, to like 4G or 5G standard or a 6G standard would be disastrous, right? So there has to be platform stuff done, but you can start applying a lot of these technologies today.
Get busy.
Yeah.
Where's the microphone? Over here. Yeah, thank you.
Okay, question for Lorcan. You mentioned about the need to have something that is more at the edge or more centralized, and clearly it's a complex decision. But can you give us a little bit of flavor of how you go about it? So, for instance, if you want to use AI to optimize massive MIMO, there is a lot of things are specific to the cell site, but a lot of things might be sort of generic, general and applicable across operators and across all sites. So how should we think about, is there some part of it that should be centralized and some part of it should be at the edge? Or should how should we think about it? And can you give us some examples?
So I mean, I'll start. Maybe Paul can have a go. So I think what we've been trying to do with ORAN, with the near real time and non real time RICs, and if you think about massive MIMO as an example, right? So if I'm trying to place capacity or I'm doing beamforming, I need something pretty close to pretty close to the very edge of that base station site. And then I need to think about the cluster I'm doing that capacity placement in and handovers for that, which might be something a little bit less real time. So and that tends to get you into a physical implementation around a cell site and some servers at a cell site, or hopefully you've got a lot of fiber and you can bring it a little bit back to a more concentration node. And then I think the implementation of the AI, and what do you think about that?
Yeah, so I think this multiple things here. So there will always be operations which you can't really offload to the cloud, because you really need to kind of take decisions within microseconds, right? So you train the model, but then maybe you need to compress that model, prune it or whatever, so that it runs at the very edge on a constrained device, and it's going to be able to give you an answer to a problem that you're trying to solve really, really fast. And oftentimes you might actually think, do I really need AI for everything? Because there's a lot of other tools that actually work all right. I'll give you one example, and this kind of edges more on research. So you can do LDPC encoding really quickly. Decoding is very hard. And people started looking at deploying AI to do decoding, and then guess what? A bunch of guys at MIT started looking at using...
Keep it short.
Yeah, Gaussian additive noise, which is basically like it's guesswork to solve the problem, and it's really quick.
Yeah. Thank you. I'm following the microphone here. Is there one over there? No, there isn't. So Dean. Yeah.
Indoor wireless and AI. How does the macro network know about the fact that there's a conference room 2 walls from the outside of the building with 80 people in it or 100 people in it, and there's low E glass, you have to get the data, the floor plan from somewhere? Do you interrogate whatever the cloud Wi-Fi controller is? Yeah, where does that come from?
It is a challenge, yeah. I mean, part of it is if you're using a mobile network and you're moving through the environments, then the fact that you suddenly lose connectivity is a piece of data that can be used, and that could then be used to infer what's going on. Some of those challenges you're never going to solve. If you've really got almost a Faraday cage, then there's not much you're going to be able to do about it. But yeah, the data can help. I think it will depend on the exact nature of the problem, but it would need some clever models to solve. Well, it's detecting the problem, and then what do you do about it?
A little bit on that, right? So the SoftBank guys have it's public, right? So they have a pretty interesting approach to that, right? So they have a company called agoop.co.jp, and it harvests UE measurement reporting, right? So if I can't see a lot of satellites, I'm likely indoor. I have direction or vector of travel, so I know I was outdoor and now indoor. And they were using that in the Sprint network to optimize quite effectively. So that has been an approach of, it was before it was AI, it was just big data, right? So, but they've been doing that for about 10 years, maybe. Worked quite well.
Fantastic.
Saved a lot of capital.
Let's get two more
live.
questions.
Yes. Okay. Joel from 4MC Partners. I'm going to ask the other question. Why are you not talking about Wi-Fi?
I tried.
I know we
Remember,
just got
I'm on
to,
Wi-Fi
we just
instead of
got
Edge
to-
here, right?
Well, okay, we just got to indoor. Okay,
Yeah.
but most people are not on cellular networks for most of the day. They're on a Wi-Fi network, so you've got telco traffic being backhauled over somebody else's connection. How is the EWG thinking about that?
I'm glad you raised that. And for the avoidance of doubt, our scope, is wireless more generally. And indeed, part of what we've been trying to do as an EWG is think about softer routes for UK innovators into wireless networks, and it may be that the
Wi-Fi.
complex world of the 3GPP network is not the most attractive network for that. So,
Like a volunteer.
absolutely, yeah. Did you want to come in on that?
Well, it's that classic thing. Myself and Mark Grayson for years have been running a tally on how much of our data is on Wi-Fi, and it's generally 95%, right? And having worked for Cisco flogging lots of Wi-Fi, it was a classic one, right? So I think we have done some work with the hyperscalers over the years around mobile data offloads, different insertions on EWG. So there's a lot to do on that. And I was going to pick up that, wireless is Wi-Fi as well as
Absolutely.
the macro.
And as things like millimeter wave open up and the new technologies like we're seeing, like reconfigurable intelligent surfaces, cell-free massive MIMO, these might open up that space to the operators, the traditional operators, and challenge the Wi-Fi for a guaranteed service. And that would need a lot of AI to drive it.
We will.
Well, it turns out that the microphones have reached a point of stasis, so this is a good point to pause. That's been really fascinating and has queued up more discussions later in the day, and indeed the work of the wireless EWG for the coming year to work with UA towards a point of enlightenment down the line. But please join me in thanking our panel very much and yourselves.
Thank you so much.
Thank you.